Hello, Physics Nation. My name is Nate Larmond. I'd like to do a Khan Academy problem from the set called Calculating Linear Momentum and Change in Momentum. A rock hits a window and stops in 0.5 seconds, 0.15 seconds. The net force on the rock is 58 newtons during the collision. What is the magnitude of the change in momentum of the rock? So this is a classic sort of trick question. If you see change in momentum, well, you think, well, I need to know the mass and the final velocity and the initial velocity, because change is always final minus initial and momentum is the product of mass times velocity. Well, that's one way to do it, but they're actually using the impulse and momentum theorem, so they are emphasizing that the change in momentum, the right-hand side right here, mvf minus mvi, is equal to the impulse, the average net force acting over some time period. So, don't fall into the trap. If you see momentum, you may not necessarily be given mass and velocity. The impulse equals the change in momentum, and with these two quantities, we can find the impulse. So a Newton applied over a second will cause 1 kilogram to change its motion by 1 meter per second. That's another way to look at it. All right, so we simply just substitute in, not 0.0, not 0.015, but 0.15. So 15 hundredths of a second is the elapsed time, and we have 58 newtons. What is 15% of 58? I have no idea. Let's see. 8.7. Again, you could say 8.7 newtons per second. Newton seconds. That's the unit of impulse, a Newton second. 1 Newton applied over 1 second is 1 Newton second. We have 8.7 Newton seconds, or you could say it in the language they're looking for. 8.7 kilogram meters per second. With this force applied over this time, you could change the momentum of 8.7 kilograms by 1 meter per second, or you could change the momentum of 1 kilogram by 8.7 meters per second. Let's just make sure I hit the buttons correctly. 8.7 is both the change in momentum and the impulse. That's the trick with these questions. Thanks for watching. See you in the next video.